Hello, I am Dr. Imran Khan. Today I will explain animation of integrated circuit fabrication and copper interconnect design. An integrated circuit, also called a chip, is an electronic circuit formed from thousands, millions, or even billions of transistors, resistors, and capacitors. It performs the same function as a large circuit constructed using discrete components. But an IC is an extremely complex device that is constructed as a single unit on a small piece of semiconducting material. The main raw material used in making an IC is silicon. Hence the fact that ICs are popularly called silicon chips. An IC is designed for a purpose and can be used across various industries such as aerospace, automotive, telecommunication, computers, and so on. The entire process of designing, manufacturing, and testing of an integrated circuit is a complex process. Integrated circuit designers design and validate the ICs, while the integrated circuit manufacturers like TSMC, Intel, AMS Austrian Microsystem, often we also call them the foundries, they fabricate and test the ICs. So in this lecture, I will explain animation of integrated circuit fabrication and copper interconnect design. So in this slide, let's start from the fabrication of simple inverter. So here you can see the simple diagram, circuit diagram of an inverter. Okay, so this is PMOS transistor, this is NMOS transistor. Okay, so semiconductor device fabrication is the process used to manufacture semiconductor devices. Typically, the metal oxide semiconductor devices used in the integrated circuit chips that are present in everyday electrical and electronic devices. So here I will explain the fabrication of simple inverter. Okay, so well mask, active mask, shallow trench isolation. So here you can see poly mask, N plus select, N plus diffusion. So here you can see P plus diffusion, VDD contacts, body ties, VSS contacts, field oxide, contact mask, contact etching. So here you can see the etching, metal mask, and in the next slide, this slide I will explain the copper single and dual Damascene process and chemical mechanical polishing. Basically, we use it for the fabrication of interconnects in our integrated circuits. The introduction of copper and low K materials has changed the basic method for fabricating interconnects. The Damascene method involves etching lines and vias features in the dielectric, a silica-based material, then filling those features with barrier and copper metal. The excess metal is removed by chemical mechanical polishing or CMP, and the wafer is then processed by an aqueous post CMP cleaning step. Dual Damascene process. The dual Damascene process is similar to single Damascene process and is used in microprocessor manufacturing for making metal interconnects. The dual Damascene process can be performed by using two etching steps: trench first, then via, or via first, then trench. But there are difficulty in patterning using the trench first method. Hence, via first, then trench method is preferred. The dual Damascene process is performed in two steps. In the first step, the copper is deposited electrochemically by using electroplating technique. In the next step of processing, the excess amount of deposited copper removed by applying chemical mechanical polishing or CMP techniques. So in this slide, I will show you this animation of whole process. So this is the layout of simple inverter we already designed in our last slide. So first I will show you the single Damascene process. Okay, so these are the steps of single Damascene process. So here you can see tungsten via plugs, intrametal insulator. Okay, so here you can see intermetal insulator. So here is this metal 2 trenches. So here you can see these metal 2 trenches. So this is metal 2 electroplating. Here you can see this is the electroplating. CMP or chemical mechanical polishing. Okay, so here we done it. So this is now the double Damascene process or the dual Damascene process has started. Okay, so this is first the insulator, then via trenches. So here you can see via trenches, trench etching. So here you can see. So this is copper, and finally CMP or chemical mechanical polishing. So in this lecture today we explained the fabrication and interconnect design of a simple inverter. So this was all for today. So if you have any question, please feel free to contact me via email. Goodbye, see you next time.